Positive correlation. Luke, what do you know?
Positive and probably because of inflation.
What about inflation?
Inflation is gonna be more expensive.
Okay.
But they're gonna put more pieces in there to make it seem like a better deal.
That's something we should probably look at. I actually made this data set about 3 years ago, before the spike in inflation. So if we look up today's prices, which we will, and connect them or like compare them to what was about 3 years ago, we probably will see a little bit of an increase.
What sets are used?
What sets did I
That's
use?
what I
That's a good wonder. Yep. What sets are actually involved in here? Which ones are costing $500 is one of these Millennium Falcon, right? Do I have a Nintendo set in here? That's a good question. Did anybody observe the X and Y axis this time? I always ask you to do that. So did you see what's down here?
Yeah, 2000.
So it's pieces in the Lego set, and then on the Y axis, of course, you have the corresponding dollar amount.
What is the Millennium Falcon?
This is probably my favorite Lego set. I got it for Christmas last year, put it together. What I liked about it is in like the building process, the inner workings of the Nintendo itself are like actually there. Like if you were to open up a Nintendo and look at it, it would match almost entirely like what's in here. There's actually, it even comes with a game. I don't know if you guys have seen this. Hey, baby, come out. Not me, I think. There we go. I think you build a little game and you put that in there. No, of course it does not play. But I enjoyed the building process and also just the aesthetic look at it. There's a television back there that you put together as well that goes along with this.
Then there's the back of that thing.
This set was not cheap. I got it for Christmas. It was the only gift I got pretty much, and I loved it. It was great. Where do you think you would place this set in terms of price?
Oh, that's pretty high.
$200.
Like $125
I
bucks.
think it's the one like.
$200, $300.
Yeah, it's in that range.
It's
It's a
Nintendo.
3,000 piece set. So each of these pieces, if you add them all up in the television back there, they came in the same box. That was 3,000 pieces. Now, everybody put your pencil on 3,000 in terms of the x-axis. There's 2, there's 4, there's 3.
I thought it was that one.
Rise up into like the middle of the data set. Wouldn't that be about here? Okay. And on the y-axis, where are we? About $300, yeah. So that is not cheap, and I'm fortunate to even have gotten it, that our family can afford sets like this. That's great. When I was a kid, I didn't get anything close to this, or we did not have that much money. So it wasn't like I was getting the crazy Lego sets. I got some, and I really enjoy the ones I got. My kids love, all 4 of them enjoy putting sets together, okay, as I do as well. From when I was a kid, unfortunately I don't. But my favorite ones were the Lego Technics, which you're actually like building like cars and
Oh, that
motorcycles.
sounds
Yeah,
good. Vroom, vroom.
I like that they had the shock absorbers and they looked like an actual car. That was kind of cool. So we got our notice, we got our wonder, now we need to identify strength of correlation. This usually is done hopefully pretty quick, so I'm gonna skip to a 4. I don't think anybody's gonna rate it less than a 4, that would be weird. If I had a 4. Anybody had a 5? Make it rated at a 6. One here. You confused me with that one. That's it. Anybody gonna put it at a 7? Okay, nice and high. 1, 2, 3, 4, 5. Okay, 5. Anybody gonna put it at an 8? Okay, that's probably the rest of us. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is everybody, okay? So we're thinking somewhere between 7 and 8. Equation of the line of best fit. Now, does everybody have a line on there?
Yes.
I see that you don't yet, Mason. Can you put a line down, please? Everybody have a line? Use your straight edge.
I think mine is perfect.
Okay. Use your straight edge. Good. You guys got lines? You don't have to change it. It's okay. I think you're gonna do well with this one. If we are placing the correlation at a 7 or an 8, it becomes easier to draw the line of best fit. So you might be right on or pretty close to what the actual line is. I asked you not to look ahead, so you guys see these 2 coordinates down here?
Yeah.
Those are coordinates of the line of best fit and approximately. So go ahead and plug in 1500, 164 to the best of your ability. So 1500 is right here. If you go up, that's 100. Just above this orange coordinate would be 150, so let's go just a little bit higher than that and put 164 approximately right in there.
Wait,
I actually got it perfectly.
on the line, that's
It is
actually
on the
what I
line.
did.
As do the other, before we do this, let's draw the other point, or label it. The other coordinate is at 4,000, so if we go to 4,000. 392 is the Y value, so that would be just under this line here, just under the 400, something like that. Go ahead and draw that line also for the line of best fit. So this is
I got it.
what I would say is the perfect line.
Actually does.
I actually have the perfect line.
Can you please extend that line all the way back to the y-axis and make sure it touches the y-axis? Like that. And you will notice that it should pass directly through the red X, just like your line did. If your line overlaps that one, that's really good. Visually, you're noticing that I think most people would go a little bit higher than that in terms of slope. Here's why. See this trend right through here? I think we're gonna follow that trend a little bit more, but notice what happens to the line. It gets shifted down because of these 2 points here. They have like a gravitational pull that's pulling the line down a little bit, so instead of being like this, it's now tilted like that. See that subtle move right there? But that's what happens when you have more points involved. All right, does everybody know what to do next? Do you know how to find your line of best
You
fit in
do the
terms of
same
equation?
at the end and it equals the y minus.
Let's do it. We should be able to work quickly because we know what to expect, we know what's coming. So here we go. M equals, I've been putting y1 minus y2. You get to choose which one's y1 and y2. Lucas, you said positive correlation, which means positive slope. So should we try to keep these numbers positive?
Yeah.
Okay, so let's do 392 minus 164. Please make sure your y values are on top. If you're gonna put y minus y and put x's in the numerator, there's a disconnect. You're not understanding what coordinates we're grabbing or like trying to achieve. Consistency here, 4,000 goes on the bottom, minus 1,500. Okay. What does that numerator turn out to be? Is that 228? Okay, 228. And I can do the math here, that's 2,500. I would suggest that we divide these two so we can see what Desmos is gonna give in terms of a decimal. So 228 divided by, oops, I had a number there, Stephen. 2,500. 0.0912. Or how about point 0.09? Okay. If I asked you to explain what that number means, does anybody in the room think they could do that? What does this number tell you?
The R square code.
Where the line,
That's coming up, we're not there yet. Nora,
the correlation.
not yet,
Where
not yet.
like, right.
This number doesn't give you the sense of correlation yet, this is the slope, okay?
Who's that? Who's that?
Not yet, no, we're not there yet. Desmos is gonna tell us the R squared value. Okay. Lucas, what does the slope tell us?
The angle of the line.
Okay, the direction of the line. What is the same as, if I say slope, what's the other word in your head? Slope?
Direction.
Oh, we forgot? Okay, rational, fraction, distance,
By that.
distance, bag. Let's go again. Rational, distance, slope, rate. Okay, rate. There's a rate here. Rates have labels. What is your y-axis label? Tell me. What's on the y-axis?
Numbers.
Dollars.
What label? Dollars. Okay. So this is dollars per, what's on the x-axis?
Pieces of Legos.
Pieces. This is dollars per piece. And that would be 0.09, which is 9 cents. So every Lego approximately costs you 9 cents.
Wow.
Okay? That's what the slope tells you. It's a rate. Of course it is. So if you just take those two labels and attach it to your slope, you have a rate. That's what you need to understand. So every piece in this set, 3,000 pieces, right? That piece right there costs 9 cents approximately. This red
That's
button
actually kind of expensive.
costs 9 cents, okay? This cord costs 9 cents. Every little piece costs about 9 cents. Now, would the bigger pieces cost more than the smaller ones to manufacture? Yes. On average, a rate is an average rate of change. It's the average price, okay? So, interesting. Do you think
So you paid $9 for one.
you could, yeah, like, that's the going rate, right? It's about 9 or 10 cents per piece. So if you went to a garage sale, or you're having a garage sale and you're getting rid of old Legos, so you just throw a bunch of old Legos in a bin, couldn't you charge about 9 cents per piece? That would be retail, so you might wanna go a little less than that because of the garage sale.
It's like
But you
five.
could probably lower it to like, yeah, 6 or 7 cents per piece, and that's still a good deal for anybody buying those, like,
In the bag, 100 Legos.
You have
All over.
90 cents.
second part. I have told you, this is the piece, you should be able to do this. This is what I need you to get comfortable with, so hopefully you know where we're going next. We're going for the Y-intercept. We start with this. This is the 5th example we've done. If you've tuned me out 4 straight times, you're like, I'm not gonna learn this. Now you need to learn how to do this. Now, how do you find Y-intercept? You start with the slope-intercept form. You plug in for the 3 things that you can find. You just found slope. M is 0.09. Plug it in, okay? Underneath M, you write that number, 0.09. Now you need an X, Y, and it doesn't matter which one you want. Landon, you want the first quarter or the second quarter?
First one.
First one. X is 1,500, okay? Take that and put it in place of X. 1,500 goes there. The Y value is 164, put it in place of Y. And then we don't know what B is. And now it's 2 steps to get to what the Y-intercept should be. Multiply those 2 together. So 1,500 times 0.09 is 135, write that down. And what do we do with that 135 at both sides? Subtract it. Yeah, it's a positive number, you're adding it to your unknown, subtract it from 164 and you'll have what your unknown is. So minus 135, that's pretty simple math there, that's 29. 29 equals B. I asked you to draw your line of best fit through the Y-intercept, or through the Y-axis. Look at your Y-intercept right now on your line. Is it about 29?
Yes, yeah.
Yeah.
Okay. Like this matches what we think is true here. This looks like somewhere in the 20s maybe. So it's not that far off. My line's not perfect. It was drawn by me. Okay, I'm not perfect, but it's close. Here's what we got. We've got a slope of 0.09 or 9 cents per piece for every Lego set on average. We have a Y-intercept of 29. And then an R-squared value,
Of what does $100?
we're thinking somewhere between 7 and 8.
Yeah.
Okay, let's take a look.
7.
The data says 0.838. Your intuition was correct. Those of you who said 8, you're really close. 0.838 is strong, right? It's right here. It's not very strong, but it's
It's a
definitely
strong.
Okay. Now I want to talk about why is this not very strong? What is altering this to even shift it into the strong range? Well, going back to my set for
Going
the
at the
third time,
500, 4,000.
you are not just paying for the plastic.
Paying for the name.
You're paying for the
brand.
name. To have Nintendo on this set, Lego has to pay Nintendo
Along with.
for the trademark of that. Otherwise, they're in copyright infringement. If they were to produce this set and not give Lego, or not give Nintendo money for the rights of this, they could be sued by Nintendo for, I mean, look, you're manufacturing something that looks like their product. You can't do that without paying them for the licensing and for the rights to that name. So Nintendo is listed here, it's listed on the controller. That ups the price of this set, okay? So if it was just gonna be 10 cents per piece or 9 cents per piece, it's probably less. To stick that on there, that ups the value. You guys see the Y-intercept is 30?
Yeah, look
Shouldn't that be 0?
at it.
If you have 0 Legos in your set, that should cost you $0. This says it costs you 30 bucks. So here's what, on average, they raise the price of their sets by at least 30 bucks, okay? Just to get some money involved in that. And then now you can look at that line and say, okay, what should every Lego set cost approximately based on the number of pieces? Look at the bottom of the worksheet. Use your line of best fit, okay? If you have 200 pieces, how much should that cost you? Or instead of using that, can we just use the rate of change? 9 cents per piece. So if you have 200 pieces, and you go to Walmart, you pull one off the rack, and you say, okay, this set has 200 pieces, then you look at the price. What should that price be approximately?
$18.
No, wait, what?
18.
About 18 bucks.
Yeah,
Okay.
I did.
That's all right. I'm gonna put somewhere close to $20, because it's an approximation. So just put it should be 18, 20 bucks.
18.
Okay? If it's not $20, roughly, it's either a name brand set, let's say Star Wars is attached to this, and you're like, oh, okay, it's $30 for this amount of pieces, that's so worth it to you. If they price that at $40, I would not buy it. It's either mislabeled or they jacked up the price and you're not gonna buy it there, which some stores will do during, like, you know, there might be holiday deals and also things where they go the other direction and see if you'll just buy it, cause if it's 2,000 pieces, multiplied by your rate of change, which is 0.09. And if you add the starting value, wouldn't that put it closer to like, so almost $200? Yeah. I would expect a price around $200. I mean, that's a nice Christmas gift. If you get a $200 gift, that's pretty nice. And like I said, that one was upwards of $250, $300. And for me, it's well worth it. I love it. I enjoyed the experience, but I don't expect to get that any day of the week. Okay, that's a special thing. 3,000 pieces. Okay, so we got 3,000 times the rate of change, plus the starting value of 29, which puts it closer to $300. Okay, that's $300 approximately. I've already talked about that. Now, here's the thing, there is no Lego set that I found that has 10,000 pieces except for one. There was one out there that's 11,000 pieces. Does anybody know what it is? Nope. What's that? Good guess. That's a big one.
Ah,
I know that one, but it's
That's
not
so-
that.
Okay,
Is it like Lord of the Rings?
it's actually, there's this one where you can make a world map. Okay.
Oh, that.
And the map is like, it's very large. But each piece is comprised, you know those little stud pieces, those little circular pieces? It's 11,000 of those.
No.
And you just take them and you just place them, and then at the end, you have the world map, okay? But the cost of that set is only like $250, even though it's 11,000 pieces. Do you see why? Because it's consistent, it's 11,000 of these little guys.
There's that trade.
And yes, it's a world map. So I would say that's an outlier, and we'll look at that when we do our research. But if it's 10,000 pieces, following this standard, okay,
You're on 9.
it should be around $900. Okay, research time. Here's what we're gonna do. I'm gonna pull up my Desmos, and I'm gonna have the correlation sitting there. Every one of you has to find me a Lego set and tell me how many pieces and the cost. Okay, everybody do the other half.